Okay, well, good morning, good afternoon, good evening, wherever you are. It's great to have everybody here with us for this ChemEng Evolution Sustainability and Environment webinar. So for the purposes of today, I'm Chris Hamlin, the chair of the ChemEng Evolution Futures Working Group, and I'm delighted to be the host of today's event. Throughout 2022, the IChemE is proudly celebrating its centenary, 100 years of organised chemical engineering in the UK. And it's the culmination of 2 years of work that's been produced almost entirely by volunteers from across the institution in multiple geographies, multiple disciplines at multiple stages in their career. You can read all about the past and present of our discipline, of which we can be justifiably proud, on the website, which was launched at the turn of the year. This discussion is the first in a series of monthly discussions, which is aimed to look at how chemical engineers can positively influence the future that is before us. So with that, I'm pleased and delighted to be able to introduce the panel that we have with us today. We've got Dr. Mary Stewart, who's the CEO of Energetics, Australia's largest and oldest specialist energy and climate risk consultancy. She also holds a variety of other roles, including President of Australia's Energy Efficiency Council and a whole heap of other things. Mark Apsey is the current chair of the IChemE Energy Community of Practice and Managing Director for Amoresco in the UK. Joanna Snape is Innovation Manager at E.ON, having graduated relatively recently with an MEng from Newcastle University. Steph Simons is Emeritus Professor of Energy Systems at Brunel University and the director of Gridport Limited. And we're hoping that we'll also be joined by Dr. Pratima Rangnarajan, who's the CEO of OGCI Climate Investments based in London, but we're having a few technical difficulties there. So hopefully Pratima will be with us shortly. The format of today is that we will have an introductory, maybe challenging statement from Malcolm Wilkinson, who's the chair of the ChemEng Evolution Sustainability and Environmental Editorial Panel, and also chair of the IChemE Sustainability Special Interest Group. Following that introduction from Malcolm, there will be a panel discussion and debate with all of the people that you see with us. Throughout that, there will be plenty of opportunity for members of the audience to submit questions to the panel. If you go to the GoToWebinar control panel that you all have on your screens, there's a section in there called questions. I'll be monitoring those and I will do my best to feed in those questions to the discussion. Obviously, we probably won't be able to cover everything, but I will do my best to be as representative as I can. One thing to be aware of is the whole webinar is being recorded, and that recording will be available to all attendees once we close, so you can always go back and review things. We will also be of documents and websites and things that get referred to throughout the course of the discussion. So with that, please can I hand it over to Malcolm, and we will bring the panel back once Malcolm's finished to begin the discussion and the debate.
Well, let me add my good mornings, afternoons and evenings to Chris's, and welcome everybody to this webinar. As Chris said, I'm Malcolm Wilkinson, and I've chaired the team which brought together all the material on this topic from the expert interviews which we did. As Chris said, you can see all that information material on the Evolution website. But I would like to start by thanking the team that put all this material together. They worked jolly hard, and they've really done a splendid job. So, as Chris said again, this is a very short introductory presentation to focus both the forthcoming panel discussion and your questions. So first, a couple of definitions, of which, of course, there are very many. The classical Brundtland definition from her 1987 report, Our Common Future, which she did for the World Commission on Environment and Development. I think that definition has proved rather difficult to operationalize. So there's a rather pithier version there by Professor Tim Jackson of Surrey University, which is easier to put into practice, providing that we don't forget the crucial intergenerational aspect. I like this natural capitals model of sustainable development, which links the three components of natural capital, that's the world's natural resources, including the systems it provides for waste, the financial and asset capital, the money, buildings, machinery, and equipment, which are the means for wealth creation, and the social and human capital, that's people and organizational systems, which are the enabler of human development. To be sustainable, we must operate in the blue area where the three components overlap, balancing wealth creation with impacts on the environment and society, and noting critically that maximizing the efficiency of wealth creation is not sufficient for sustainable development. Unfortunately, what we have had since the Industrial Revolution, and still have today, is a system based towards depleting natural capital to secure growth. And under these circumstances, we cannot achieve sustainable development. Worse, we are now in a situation where our rate of consumption is overshooting the planet's biocapacity, and continuation at these levels is not an option on a global scale. Consumption, particularly in developed economies, is the driver behind climate change, biodiversity loss, resource depletion, and the inequality between rich and poor. But addressing this issue is politically very clearly sensitive, as we shall see. The conundrum, then, is how we can meet the UN Sustainability Development Goal of raising the living standards of the world's poor without further exceeding planetary boundaries. Startlingly, if we set an income of $30 a day as the minimum target for a reasonable standard of living, and if Western countries accepted zero growth, to enable poor countries to grow, the world's economy would need to grow of the order of fivefold to achieve this target. We clearly need to do something different. To ensure the well-being of current and future generations, we need to start to value the environment in economic terms and translate these values into market incentives via pricing policies and regulation. Critically, we must move away from using gross domestic product as a measure of economic performance, since it values material gain at the expense of environmental loss. Finally, we must make a significant and sustainable change in the way we utilize the planet's resources, material resources. And since the conversion of materials into useful products is fundamental to chemical engineering, we must, as a profession and as individual engineers, take a prime role in addressing this issue. But as I've outlined, the changes required are not only technical, but political, social, and economic. And to make an impact, we must exit our technology safe house and get involved in these wider aspects. Easier said than done. And to do it, we need to change our mindset and approach and develop our systems-based evaluation toolkit to drive forward a sustainable world. This is the topic for the panel to discuss, and what follows are some initial thoughts on how we might change. Firstly, we should understand that development, and by that I mean make improvements in the quality of life, can be different from growth, meaning increases in gross domestic product requiring more material things. We must realize sustainable development is an ethical concept like justice, and consequently, we must accept a set of ethical responsibilities that go with calling oneself a chemical engineer. The reference here is to the set of ethical values from the Engineering Council, which has been adopted by the IChemE. But additionally, the Royal Academy of Engineering are about to launch a new set, in fact, next week. And the new Sustainability Hub on the iChemE website features training material on the topic of ethics. Human activity is stressing the resilience of all natural systems, and in many cases has already led to extinctions. So we must learn to design and build systems which lie at the intersection of the three components of the sustainable development model I showed at the beginning, and avoid further degradation of the environment. To deliver this objective, we must apply the concepts of the circular economy using a broad systems-based approach based on our technical and economic evaluation specialisms, overlaid by our sustainability principles. This will inherently lead to solving complex, multivariable problems and a likely choice between non-optimal solutions. Outcomes should be robust, representing those least likely to be wrong under several potentially different operating scenarios. In this complex world, clear and accurate communications become even more important. We must learn as honest brokers to present scientific and technical data clearly and without bias, and help non-technical personnel interpret that information so that government and corporate decisions are soundly based. We will need to represent all the challenges that I've outlined in multidisciplinary teams of technical and non-technical personnel. In conclusion, this, I believe, is a wake-up call for chemical engineers, both collectively and individually, to seize the opportunity to drive progress to a sustainable world. This is a challenge we are uniquely trained to deliver on, and if we don't accept it, who can? Thank you very much. Back to you, Chris.
That's wonderful. Thank you, Malcolm. And if I'll now invite all of the panelists to turn their video back on and come off mute, that would be great. I think I saw Pratima was just joined as we went into Malcolm's presentation, so hopefully she'll join us too. Okay, what I would like to do then, if I may, just get the discussion moving. Actually, before I do that, just remind everybody in the audience that we are happy to try and answer questions in the GoToWebinar control panel. There is a questions section, and you should be able to type questions in there. I'll be reviewing those and I'll try and feed them in. So you'll certainly make my job a lot easier if you put some questions in there rather than rely on my imagination and creativity. Nonetheless, let's get started. I'm going to pose the same question to each of the panelists just to get the discussion going. And that question is this: based on what we've just heard from Malcolm, what, in your opinion, is the most important issue or contribution that the chemical engineering discipline needs to address if for us to be able to achieve the sustainable future that we all aspire to and that Malcolm mapped out? So if I may, can I start with Mary?
Thanks, Chris. I mean, from my perspective, the biggest issue that chemical engineers have to engage with is uncertainty. So chemical engineers design processes and systems that need to operate, and I'm going to say optimally, as a caveat, for decades. And these design challenges are increasingly complicated by uncertainty. The core sources of this uncertainty are that as we decarbonize, consumption patterns across the global economy will change drastically. And we need to consider the long-term outlook for the products we're producing and guard against stranded assets. So we need to understand the role of our process in the global circular economy. We also need to understand the transition risk of changing policy and the resulting pricing implications that can present significant uncertainty in what we're going to be allowed to emit and that what we'll have to pay for these emissions. And this has a huge impact on the business case for the processes and the projects that we're looking at. We also have to recognize that the changing natural environment, as temperature rises and weather extremes change, the ambient conditions for which we design will be different. And we have to engage with a much broader and much sharper set of ambient conditions. The impacts of climate change on health and well-being will also change how people are able to engage with the processes that we design and build. And it's these two final sources of uncertainty that are both catastrophic and existential that we often pay little attention to. Particularly, we might look for the catastrophic risks in our HAZOPs, designing for floods and cyclones, but we pay scant attention to the existential risks of increasing temperature and changing rainfall patterns. So it's against this background of increasing uncertainty that we look at chemical engineers and say that we need a significant shift in our focus. We have to design for an unstable natural environment with much greater extremes in weather. We have to understand legislation and policy and look to future changes. And we need to pay attention to economics as well as the changing face of economies, not only in our own countries, but also globally. And so this brings in the point that Malcolm was making about it's not all hard technology stuff. We've got to get good at the soft technology side. We've got to look outside our bubble, and we need to be able to communicate. But it also ties into what Malcolm was saying about there is not one single right answer anymore. The best we can hope for is to design that system or that process that is least likely to be wrong in the face of these huge uncertainties that as chemical engineers we're trying to build into our design process. I'll leave it there and see what questions we get. Thanks, Chris.
Yeah, super, Mary. Thanks. So, I mean, so Mary, you talk about uncertainty and designing for that kind of radically changing environment. Mark, I wonder, yeah, what's your perspective on that single biggest issue for the chemical engineering discipline as you see it?
Hi, good morning, everyone. Yeah, I think I mean it's a massive question, right? But I mean, as chemical engineers, we're working in some or probably all of the most energy and resource intensive industries on the planet. And I think as we reflect and celebrate the 100 years of ChemEng and our part in all those innovations that have delivered the quality of life benefits that we've talked about to society, and everything from clean water and food and medicines and all the other products that come out of the processes that we design and operate. I think we do have to really also recognise our responsibility to protect the planet on which we live, and Malcolm's talked about that quite a bit. But we must find ways to make the things that society needs and wants with the absolute minimum impact possible on the environment, bearing in mind our understanding now of what those impacts are in terms of the planetary boundaries. And I think that's one of the things that led us as an institution to prepare and publish the position statement on climate change that we did at the end of 2020, where we've, for those of you who've not seen it, restate the scientific principles associated with that, but also I think made some important commitments as an organisation, both in terms of what we're going to do as ChemEng, but also what we should be looking to do as ChemEng members in terms of thinking about ethics and code of conduct and additional sustainability training in universities. And also, and perhaps most significantly, what those principles and commitments mean for the sectors in which we will work as members. And there's a whole programme of work which Mary and others are involved with to look at the different sectors and prepare plans as to how we're going to transition, as I say, the energy and resource intensive industries we work in so that they're better. So I mean, I think as chemical engineers, a couple of things I'd just point out, Chris. I mean, firstly, if you've not seen the position statement, I think take a look. I think it's really important to look at that in the context of our own areas of influence and where we work right now, because we can make a massive difference. And we should challenge ourselves critically to look at the designs we're doing, the plants that we're operating within that context and find opportunities to improve. And then in doing that, and shameless plug for some of the energy community of practice work, it's, I think, helpful if people are not sure where to start to look at the Energy and Resource Efficiency Guide, which we published back in 2019, which sets out 10 core principles, which can really get your brain going and thinking about the sorts of things that you may be able to do within the context of the design and the processes. And I think if we apply those principles to all of our own areas of work, then together we can make a huge difference, Chris. And I'll leave it there because lots more to come, I think.
Excellent, super, thank you, Mark. So if I may, I'll pass the same question on to Joanna.
Sure. So I think there's two parts that I have in mind for this. The first part is sticking to known processes. So I think we live in kind of an age where very big industries know what works for them, what makes money, what processes are able to give them the best revenue or the best success in terms of business. I think sustainability now is becoming more popular, and it's becoming more of a key word both in industry and in university, and just like socially in general. It's becoming more popular, or more people are becoming aware of that. And I think lots of big organizations maybe don't know exactly how to make their processes more sustainable, but still keep that revenue coming into the business and ensuring a successful business. So I think in that respect, young people or people coming straight out of university have a really powerful role to play, in that at university you learn everything, or you kind of know the new research that's out there in terms of making processes more sustainable. And I think it can be really scary kind of going from university, where everything is very theoretical, into industry where there are already established processes, and it can be easy to feel like I have to follow this, follow these methods, follow these processes, you know, do what I'm told because I've got this new job. But actually, organizations should be hiring graduates, and I think they are hiring graduates really to bring in that new knowledge from university, and to provide that fresh set of eyes to look at things and think, actually, there's a lot that can be changed with this process very easily, to make it cheaper for the company, to make it less environmentally harmful. And it's just about kind of voicing out your opinions and also justifying your ideas. So there's a reason at university that we learn the economic side of things as well as the technical side of things, is so that you know how your processes or your ideas can impact a business from a financial perspective. And at the end of the day, that's one of the most important things in any business. So yeah, there's that part of things. I think that radical change is very important now in the road to sustainability, and finding out how we can make existing processes more sustainable. And on that point, I think I wanted to talk a tiny bit about something called globalization. So globalization, again, is something that is very important for large businesses, especially because they want to increase their market potential to a wider audience, I suppose. But I think, or what I do in work anyway, is I look at something called energy communities, where we're localizing energy and making energy kind of cheaper and more accessible to everyone. So not everyone can afford to purchase their own PV panels, for example, but what energy communities do is enable the everyday citizen to be a part of the energy transition, and to be able to consume renewable energy and feel closer to it without having to purchase their own panels. So I think in chemical engineering processes, there's a lot we can do to localize processes and make it more accessible to the product, more accessible to citizens. So process intensification, that's a big one, a big chemical engineering concept, I think, that has a lot of potential, where it's essentially making processes smaller, more affordable, less energy intensive, more accessible to customers, and easier to scale up. So yeah, these are some ideas that I had, I think, which could be really powerful going ahead.
That's really insightful. Thank you, Joanna. Steph, what your take on the impact and the need, how we as a discipline need to adapt and change?
Okay, thank you, Chris. I thought you were going to say follow that, Steph, because the disadvantage of coming later on in the panel is following on from some wonderful comments from my colleagues there, and I think Joanna's really stolen really spiked my gun, because I was going to make some similar points, and I think she's really hit the nail on the head. For me, I agree entirely with what's been said. If I want to add anything more to that, it's really about not forgetting that ethical issue and that inclusivity that is part of the UN Sustainable Development Goals. And obviously, you know, we mentioned it in our climate position statement that Mark mentioned, but I'm not sure chemical engineers really understand how to engage in that, or they do understand, are making the opportunities for them to really start to address, as Joanna said, for instance, energy poverty and the unfair distribution of energy. And to me, that is a crucial issue. I think chemical engineers, we have the tools, and it's not by accident that I sit on the IChemE's DigiTag, the Digitalization Technical Advisory Group. I sit on that because in my business, you know, we're using AI and machine learning to really improve the way that we produce and consume and distribute energy to the grid, hence Gridport, the company that I founded, so that we can then use spare capacity to distribute to those that can't afford energy or don't have energy, and eliminate energy poverty. And it's this kind of creative thinking that chemical engineers need to get involved with communities, as Joanna mentioned. I was very lucky to represent the IChemE at COP26 last November, and what really struck me in the session that we were in was really about community-led action of the type that Joanna mentioned, and certainly compared to COP21 in Paris, which I was also at for the IChemE, there was a lot more going on now. And it struck me, though, that what really is needed is some systems approach to those community projects, bringing things all together, because if we can crack the problem of balancing our energy grid, and I think that's a really crucial problem that chemical engineers can really focus on, then we can bring much more renewables in and really start to see the end of the need for fossil fuels. At the moment, we rely on those fossil fuels to provide that balancing, and that's obviously not going to help us ever achieve net zero. So the key point is, do we really fully understand how we can engage in that societal capital issue that Malcolm really stressed upon? And I think the financing of these projects and the distribution of finances and the policies and regulations that go with that is a crucial issue. And maybe that leads nicely to Fatima, who might have some comments about that. So,
absolutely. I was just thinking that, Steph, you've given me the great segue into Pratima, but just as a little kind of alert to the panel, we're getting quite a lot of questions about this balancing social versus natural versus financial capital. So I'm trying to craft a question around that. So you might want to be thinking a little bit about that to prepare, you know, what you might say next. But Pratima, I mean, that's Steph gave it a great introduction to the whole kind of world of financing and what have you, which is very much kind of where you work. But again, I wonder, what's your take on this chemical engineering as a discipline's contribution to addressing these issues, and where's the potential and what's the need?
So Steph, I'm last. So I have to add in the fact that I definitely have the slimmest margin. And then Malcolm set us up so well that I had to rethink what I actually wanted to say. But it's great. I think it's fantastic to be on this panel. Thank you for the invitation. I think when we look at the challenge of what we have in front of us, it's actually three parts to it in terms of our life on this earth. Right? And I think of it in terms of our kids and the grandkids. And what are we going to leave for future generations? And it's a three-part problem. Now, our consumption of resources, Malcolm brought this up. I think last year was July 29th that we went from a positive to a deficit on this planet in terms of consumption. And every year that date comes in earlier. So I'll try to use some numbers. Then the systems waste. All our systems that we've got developed are wasteful. there's less than, generally 50% inefficiency, whether it's in your food system or most industrial production, transport. Efficiency numbers are quite low. So half of these resources that we're consuming are not used for useful work product. And third, there's the waste piece from it, which is the emissions, 50 billion tons per year. Doesn't go anywhere. Those molecules just get thicker and thicker blankets. So that's our tripod that we have to work with. And I think that's where chemical engineers come in. We do systems, we solve systems problems. Chemical engineers can look at a system from the consumption end to the efficiency piece of a process, and then look at our product and then look at the waste. And we can then figure out what is the best possible answer. And that's really important because we keep going to how do we mitigate the issue, but we've got to also say, are there processes? I think, Joanna, you brought this up, and Steph, you doubled down on it. Are there processes we can fix today so they don't create as much problems for the future? And I'll take one example. I worked in battery storage. You look at EVs. We can't just say EVs are great and diesel's bad. Well, and we need to look at all the entire system, from the mining and the challenges from minings and minerals to the efficiency of the processes to build the batteries and to build the materials for the cars, all the way to the context of usage, which is it powered by coal electricity? And I worked many years in China, which is what the EVs are powered by there, or is it powered by renewables? So in the context of the use, we have to pick the best solutions. We can't wait for the end. So I think that's the first thing the chemical engineers can do, is actually solve the systems problems and let us have the discourse and make decisions with data. The second one, I double down with what Mary said and Malcolm, we need to speak up. We cannot just speak to a cave of other chemical engineers like we tend to do. And I think when we speak up, we have to speak up with real recommendation, not just the pros and cons and the puts and takes, but here's, stakes in the ground, and we have to join society in this conversation. And the third, and this is a detail, but I really do believe that chemical engineers should drive home that driving efficiency in processes is a badge of our honor. I go from company to company and I look at the financial sector, you brought it up. We reward new things, we reward a new shiny product. We don't reward cleaning up our systems. And those chemical engineers who work on that in industry do not get the kudos. We've got to make it our badge of honor because we're wasting resources. So I'll stop there.
Excellent, thank you, Brandon. That's really, really insightful. I like the badge of honor. I've written that one down as one to make sure we take away and do something with, because that's something I think the IChemE potentially could really, we could start to address that tomorrow if we chose to. So there's my challenge for IChemE people that are on the call. Let's get that one done. Okay, so there's a lot of discussion in the questions about methodologies and complexity and managing the complexity. I'll give you a couple of kind of sample questions, and then I'll ask the panel to comment on this. So one was, are there any tools available that make the complexity manageable without oversimplifying it? A couple of people have made the observation that 20 or 30 years ago, chemical engineering and the process industries as a whole decided to tackle safety, both process safety and personal safety, and did an extraordinarily good job of that, using things like HAZOPs and LOPA and all the rest of it that we all understand. So we proceduralized them and methodicalized, if that's a real word, made those processes methodical, objective, and repeatable. There are sort of signs of some of that, I think, in this space. LCA is probably the closest, but LCA, I think, is as riddled with problems and subjectivity as it is a helpful tool right now. That would be my take, but maybe other people would disagree. But so really, the appeal to you on the panel is, what are you aware of, or where do you think the opportunity is for us to create a method for evaluating prosperity and sustainability that can be systemically applied in an objective way? So if we kind of roll back to the beginning again, Mary, do you want to? I know you work in this area a lot anyway.
I thought you'd go with start in reverse order. So where I work, we can't get rid of the complexity, because if you get rid of the complexity, You get rid of your understanding of what your problem is. And you are no longer, you can't even report what you're doing correctly. So where we're working in climate risk, we've just released a paper that points out that firstly, you can't use the past to inform the future. And there is a lot about climate change that is unknown and currently unknowable. However, people put a risk metric on that. And then because there's a risk metric, there's an inference that you understand what your exposure is, when in actual fact, you don't. And then if you report that risk, ultimately, you could be seen as greenwashing. It gets into the whole finance debate, and you could have a regulator problem because you said my risk was known, and therefore I could understand my financial exposure. So where we work, you can't get rid of the complexity. You've got to accept the complexity. I mean, it gets back to the old story of risk, where when they were circumnavigating the globe and where they hadn't gone on the map, they would draw a dragon because they hadn't gone there yet. And for all you know, there might be dragons there. And where we're operating at the moment, if we don't know what's there, we have to remember that there might be dragons. So simplifying things is not the right way to go. Unpack the dragons, work out where they are, keep them on your shelf and remember they're around. Potentially simplify what's left. Looking at what happened with HAZOP and, sorry, with a focus on safety and the resulting tools, what came first was a desire to change. What came first was leadership and commitment from the highest level of companies to say we have to do better. And that's what we have to learn from in sustainability. Trying to, you know, it's the concern we had going into the COP. The perfect will always be the enemy of the good. It is much better to start moving in the right direction and potentially, you get it 80% right, but at least you're moving in the right direction, and do that with serious senior management commitment than to try and work out exactly what is the right tool for the problem I'm trying to solve. Be committed, take action, and actually just do something. And that's my last comment that I'm going to make now is a lot of companies are trying to work out what their pathway to net zero is and what are their first and second steps. And a lot of them are saying, well, I'll just wait 2 years because there's a new technology just down the track and I'll wait for that one to be ready and I'll use that one. The mistake is not choosing the wrong technology. The mistake is not acting. And I think there isn't a perfect tool. There isn't an exactly right way. It is absolutely a function of your context, but be committed, get your management on side and actually start taking action.
That's great. Thank you, Mary. Mark, what are your thoughts on, making it manageable but not oversimplifying and handling this complexity?
Well, first, I'd agree with a lot of what Mary just said. Actually, I think it's a really good way of visualising the complexity that exists not only in this problem but in a lot of problems that chemical engineers face. And we're used to dealing with that complexity and understanding it, and then designing or coming up with solutions to solve those problems. So I don't think we should be scared of the complexity, but I think we should understand it as Mary articulated, and then use and understand the principles of the things that I mentioned earlier. Really, the things that we put in our climate change position statement, the sort of very high level, and appreciate if you look at the energy resource efficiency guide, it was written in a way that has 10 principles to help get you thinking about the different aspects that you need to consider when designing a process or a product or a system in this context. And so, yeah, I just think we shouldn't be scared of the complexity, but I do think we've got the skills to understand that and then articulate and explain it to others in a way that makes sense.
Yeah, I wholly agree. And there's also there's a large body of work around nonlinear complex systems as distinct from complicated systems, which I think we could really usefully draw on. I think as a profession we're not proficient around yet. Joanna, I was just kind of wondering, your experience, you're, dare I say, certainly the most recently graduated of all of us. So you've been through the university system most recently. What's your take on how you were taught and the tools you were given in terms of them preparing you for this and you're dealing with the complicated and the complex, but in a way that enables you now in your role as an innovation manager to make a persuasive case to people that aren't maybe technically so I was going to say competent, that's probably too subjective a word, but I think you know where I'm coming from.
Definitely. Yeah, I think, well, there's obviously the ones that we all know, like we discussed already, like HAZOPs, risk assessments, things like that, that we look at in industry as well. But then there's also, I guess, more what I've learned in the past couple of years, like project management tools, which are quite simple tools, really. So like SWOT analysis, which I think lots of people are familiar. So strengths, weaknesses, opportunities, and threats. And also VUCA analysis. So that's volatility, uncertainty, complexity, and ambiguity. So these are kind of simple project management tools, I would say, that encourages one to look at a process or a project from start to finish, and in kind of preparing a business case or setting up this project, trying to use these tools to help you think what could happen, and how can we be best prepared for that. What's likely to happen? Are we willing to accept that this is going to happen? That kind of thing. I think what's been said already, I completely agree with. You can't always avoid complexity, but how are you going to deal with it, and what measures are you going to put in place to be able to approach an unknown threat that you've never experienced before, for example. So I think, yeah, those simple tools that help you just look at the bigger picture and look ahead and encourage you to ask the right questions, like VUCA or SWOT. I think in itself, they are quite useful already. So yeah.
That's great. No, thank you, Joanna. Actually, VUCA is not one that I've encountered before, so I ticked my box for having learned something today. So thank you for that. Yeah, Steph, any kind of comments from your side of things?
Well, again, I've been listening, and I've sort of changed my mind a few times of what I wanted to say. It's always nice to follow Joanna, because that's made me think of my own experience when I was at UCL as a young lecturer. I was very keen to have sustainable development projects within our design projects, and I invited a professor from TU Delft, whose name escapes me now and who's long since passed away, and they actually had projects with their local communities, and I thought that was fantastic. And he came and spoke to the staff at UCL, and I think he just scared the life out of them, and so that really never came about. And I, as an accreditor for chemical engineering programs, I go around the world and around the UK, and I don't really see that much connection of our design projects with the kind of things that we're talking about now. We sort of pay a little bit of lip service to it, but we don't really give the students enough practice on how to think beyond their disciplines and beyond engineering, if you like. So I think that's something that we should, as a tool for our students, we should really re-engage with that. One of the problems, obviously, is that you need to have all those different disciplines and experience with them, and also the university processes often get in the way in terms of awarding students credits, etc. But I think those are challenges that can quite easily be overcome. So I think we're going to give our students the necessary tools, and yes, more on modelling and stochastic processes and those kind of things. I think those are really important, and we've recently adjusted the IChemE accreditation guidelines to bring more of that into the curriculum. But if we're really going to make a difference with the sustainability issue, I think there needs to be much more multidisciplinarity, and I would like to see quite a big focus on that.
Excellent, thanks, Steph. Now, Pratima, you're last again, which means you've had to do all of that rethinking. But if I may, I'm going to introduce the next question as well, because what I'd like. So the next question is really about the societal side of sustainability and the requirement to balance financial and natural and social capital. And actually, the SDGs, many of them are framed in terms of things like quality of work, equality. There's a whole variety of societal goals as well. So kind of related to both of these, to what extent do you feel the market can be if you like, a simplifier of this complex system? Markets do control and moderate complex systems inherently, right? But they can work well and they can work badly. What do we need to do there to make the market and the financial systems more effective without ripping them up and turning them, starting again? And does that tell us something about how we get into that balancing the societal aspects of sustainability and the interdependence between that and the environmental ones?
Thanks,
and then what
Chris.
we'll do is we'll reverse the flow through the panel. So we'll end up back at Mary eventually, okay?
I am very pleased to know that everyone else has to also suffer the question, but it was an excellent question. So I'm happy and pleased just to do, and I think they are both connected. I think the issue that we can deal with complexity now, especially with computation and all the tools we have. But what is very difficult to deal with is lack of clarity on the outcome. If we are clear what our destination is, we, with our tools, our intellect, humans can handle complexity. And we've shown this over centuries, right? In terms of all the innovations, we're off to Mars or wherever we are. So we have to be clear what outcomes we're looking for, whether it's a financial system. Our financial system is very important, and our government policy is really, really important. What outcomes are you going? So Malcolm started us off on talking about consumption. Consumption doesn't come in a vacuum. The fact is most companies are measured by growth. If you measure companies and GDPs by growth, and we have only about 7% recycling worldwide, then you are going to double you're going to constantly increase your consumption to deliver growth, because we do not have a cyclical economy. And I'll throw some more numbers. 6% GDP growth, it's geometric, so it means that you double your GDP every 15 years. Right? And Malcolm used Tim Jackson's book. It's well worth a read if you get a chance. It's called Prosperity Without Growth. And he makes the case for this. So imagine GDP doubling every 15 years, recycling less than 7%. That means your consumption will double every 15 years. That's a scary concept. And so people who say it's because of population rise, population is only growing at 1%. So that doesn't explain it, right? And so I think the outcomes are so that 6% GDP actually results in all these things that happen behind it. So what I would say is, and then I think Mary, you spoke about leadership, right, and safety. That's because leaders said we want 0% fatalities or 0 accidents. They put numbers. So the outcome was clear. Everybody can get on it, right? And I'm sure, Joanna, you see this, Mark, Steph. So I'll give you a couple examples from my world. When I first took this job 5 years ago, we invest in carbon reduction. And I was told we have no way of measuring methane or methane, right? And therefore, of course, we couldn't fix it. So look, today we've invested in satellites, aircraft, drones, AI. We measure 300 million tons of methane just this last year, emissions, right? Carbon dioxide equivalent of methane. We've only mitigated 15 this year, right? Our company, our investors. Now, that 15 is triple what Tesla did in this last year, right? So 26 billion a market investment versus our small pittance for the year. But because we're focused on carbon reduction, we are able to deliver more, because we only invest if we can look at the systems problem and decide that the solution actually saves carbon. So it's that laser focus on what we want to deliver. I'll do one last one, financial industry, because I'll try to keep bringing that in. I think, Chris, you asked me to do that. Investors all over, I think in the last 18 months, we saw $60 billion worth of new funds announced in climate. but most of them don't have targets, right? And most of them don't have targets because they don't know how to calculate the targets on reduction because of the complexity of the issue. So we spent 2 years developing how to calculate carbon reduction from forward-looking investments. And this last year, we took it as open source. So we're going to share this widely with any other investors who are interested, because we believe that if we don't use that $60 billion properly, we could actually have a negative effect on the market because the market will give up. So to me, everything simplifies if we're simple, we're clear on where we want to get to.
Excellent. Well, thank you, Pratima. Let me pass that. So let me pass on to Steph then, right? You've worked in some interesting parts of the world that have some interesting challenges around wealth creation and natural resource depletion, I know. So I wonder what, does that perspective, bring any insights to you?
Well, actually, that's very helpful, Chris, because I was wondering what I was going to say. But but yes, well, I think you're referring to. Well, I worked for many years in Kazakhstan, and in fact, when I first went there, I'd never heard of the place, and then ended up being the founding dean of what became Nazarbayev University in Astana, a founding dean of their engineering school. Prior to that, they had no chemical engineering programs in Kazakhstan, similar to the situation across the whole former Soviet Union, actually. And I found that quite amazing. And hence their chemical processes were extremely inefficient and still are in many cases. And what I was struck by was actually it was the UN that influenced the decision for Kazakhstan to really start focusing on chemical engineering, because the UN had human development program had realized that Kazakhstan's poverty and environmental damage, etc., was linked to the fact that they didn't have the skills required to really deal with these issues. And so I wrote an article actually that was published in the Chemical Engineer magazine about this, and about how it was a privilege for me to really see how, as a chemical engineer, what my role was and what our role is in raising human development, raising human prosperity and the health and the environmental pollution, all these things. And I think in the UK, and the US and other well-developed places, it's very difficult for us to see the impact that we make in those regards. And so I like to think that by introducing these programs, not only in Kazakhstan, we also introduce them in Russia as well. That's going to start making a difference. In terms of, I think your question at the beginning was about markets, and from my own personal experience, back in the 80s, I was a vegan, and there wasn't a single vegan product that you could buy in mainstream shops. You could get a few things from Holland and Barrett. Other shops are available, but you had to buy baby milk, powdered milk, SMA milk, if you wanted to have soya milk, things like that. And now vegan products are everywhere, and that's a real market demand, and it's really fascinating to me to see all these products. What I'd like to see is a similar impact on non-sustainable products. In my own town here, I live in the smallest town in the UK. We've gone completely package free now. So you go into local shops and you have to bring your own containers or to get your produce. That drives a market. I think people like Joanna, and the more we get like her, we can really start to make a big difference to that market demand, and hopefully influence the businesses that are producing the products that we want. I think I'll leave it there.
Okay. Yeah, thanks, Steph. So, I mean, Joanna, you kind of represent kind of the new generation of chemical engineers coming into the profession here, and I kind of sense that new generation is maybe much more inherently socially aware around issues like equality and impact than maybe my generation was as we went through. I have to accept. I was described as an industry veteran a couple of days ago, and it's the first time I've ever been described as a veteran, and I'm still struggling with that description. But nonetheless, I guess I am. But you know, what's your take on your generation and that group of chemical engineers that you represent in terms of how societal sustainability, let's call it that is balanced against prosperity and natural resource depletion and things? How does your generation perceive this?
I mean, I think it certainly is quite a trendy thing, being sustainable and changing your diet, for example, changing the way you shop. So wearing secondhand clothes, for example, that's all different. I think it's all becoming attractive, or the label of this is a sustainable product is becoming more attractive to people my age, I suppose, or that's what social media, I guess that's the message that social media is trying to portray, is that like these products are sustainable, buy them, kind of thing. And I think, yeah, veganism is becoming more popular, you know, all that kind of thing. It's more of a trend than anything. But I don't know if many people really look behind these labels and think, is it actually sustainable? So what I've kind of found, what I'm learning still, is that it's powerful to feel close to that product. And I think that's why small businesses and local businesses thrive so well. You know, these days, you know, a good restaurant is a local restaurant. People think that the special restaurants are the local restaurants and the franchise restaurants are like for every day, I don't know. But there's something really powerful about feeling connected to that product and knowing that it's sustainable and knowing exactly where it comes from. So I think in sustainable growth, glocalization is becoming more popular, and I think that's really good, because I think that's key for sustainable growth. It's basically taking into account actually the people that live in that local area, the regulations that are in place there, the culture, the type of materials as well. So for chemical engineers, when you look at processes and you want to start selling an end product in a particular location, how can you make most use of the materials, the raw materials that are available in that location you're selling at, and will the local community be receptive to that product? But I think that's how more and more people can actually feel closer to sustainability, and it is knowing where everything comes from and being able to know it came from here and I feel closer to that kind of thing. So yeah, it's a difficult question, I think, to answer in a structured way, but hopefully I was able to give some.
No, thanks, Joanna. It's, you know, because it's all about different insights and different perspectives, which is, you know, what we're trying to explore. Now, where we're at the bottom of the hour right now, we were scheduled for an hour. What I will do is, you know, if the panelists are happy to, we'll finish off this round and I'll ask for a closing statement from each of the panelists. So the people that are already out of time, I apologize. You know, you can catch up on those final comments on the recording when it's available. But just for completeness, let me kind of pass on to Mark and then Mary. You know, this whole balancing societal impact and societal sustainability with the environmental side of it. You know, what are your thoughts on that?
I think the question was about societal balance, right? And I want to just follow on from a point Fatima made about clarity on outcomes. I think that's so important. And if, as chemical engineers, we're here and we're serving society, we've got to ask the question: well, what does society really want? And I think, yeah, in recent times, perhaps policy globally has been driven exclusively on GDP, which drives certain responses and certain solutions, and people and chemical engineers have responded to that demand. But I think that's moved on now, and I think that we should get involved with the conversation about what society wants. It seems to me, and there's many surveys out recently about people's concerns about climate change and biodiversity loss, and being quite high up in people's priorities, and we've seen it in demonstrations and just globally, people responding to that threat and saying we want something to be done about it. So I think it is shifting away from exclusively GDP, and I think that's encouraging. I think as an institution and a body of engineers, we should respond to that call and react to that. I think if we want to talk about economics just quickly, and if people haven't seen it, I would recommend a different take on economics. If you haven't read the book Donut Economics by Kate Rayworth, it's a really good read. It links the planetary boundary question with the UN SDGs and the sustainable goals, and tries to push you and think about a space in between, which is both good for the planet, but also good for some of the inequality and injustices we've been talking about, and sorting those out. So Chris, I know we're running out of time, but do give that book a read. I think it's a great one.
Excellent. Yeah, no, I highly recommend that myself as well. Thank you, Mark. We'll try and, as I say, we'll put the links to the books that people have mentioned and things in the follow-up email for all the attendees. So we'll reference those for people. Mary,
I'll give you a quick answer. Coming from the land of the climate policy vacuum, I will say that markets are a huge driver for change. We have no policy, but we have the single largest installed capacity for rooftop solar on a per capita basis anywhere in the world. The market is moving and companies are reacting to that. And because the market is moving, it's not a balance anymore. We're not looking for the balance. We're trying to stop catastrophe. We've passed the balance point on climate. And I think that trying to think of this, we're going to find a point where everything is in perfect balance. We actually just got to stop doing the damage we're doing. And the markets are a very clear signal. Finance is moving, money is moving, you can't get capital, you can't get your project started, you can't get off the ground, you can't get insurance. It's absolutely pushing companies to change what they do and how they work. But we mustn't forget that there's going to be a bit of emissions left, that somewhere along the line, we are going to have to find technical solutions for some of the emissions. So the markets are a good leveler and they're a great way of building momentum, but ultimately we will have to find some of the technical solutions.
Super, yeah, no, I think a very, very valid point. Yeah, thank you, Mary. Okay, so just to close everything out, if I may, so the same question to everybody in the panel. We'll try and keep it as concise as we can, but the question is, can you give us your favorite example of an old school, linear, unsustainable process or business or product that has somehow managed to put itself on a sustainable footing? And does that give you cause for optimism in terms of direction and velocity and where we're going to go to? So Pratimir, if I may go back to you, what's your favorite example that might be inspirational to everybody else, and what gives you cause for optimism? Hopefully they're the same thing. I don't hear you.
Sorry, cement, responsible for 7% of about 67% of global emissions. We emit 750,000 tons of carbon dioxide for every million ton of cement we use, and cement is the most used material after water by every human. And we've invested in a company that can reduce carbon dioxide by 70% and reduce water consumption by 80% in cement. Small startup, we're working on scaling it up. Humans are amazing, but I'll leave with a final comment. If everyone can take away one thing, it's let's not waste, whether it's at work or at home. Let's conserve resources. Thank you.
Thank you, Pratimir. Steph, how about you? Your favorite example, and where does your optimism come from?
That's a big question. Along the lines of what Pratimir just said, see, I was a founding member of carbonate systems, which obviously treats waste with CO2 and makes building materials out of waste. So I think certainly over recent years, that whole reduce, reuse and recycle has certainly made great strides. There's a lot more we can do, of course, you know, it's good now that we're particularly focusing on plastics, and there's lots of really great ideas coming out on what we can do with plastic waste. Particularly even at Brunel, there's an invention which is about the size of a washing machine, and you can have it in your utility room in your house and throw in all your domestic waste in there, and it produces energy and bio oil and all sorts of things. It works on pyrolysis and heat pipes, and as a really great way of reducing waste from domestic consumption. So that's probably a good example. Yes, I am optimistic. I'm an optimistic person. If I hop back to COP26, what I saw there gave me a lot of optimism, lots of community-led projects, and lots of pressure from finance, particularly in the sector that Fatima is representing. You know, that the whole oil and gas sector, I think, is really starting now to, or having to respond, but is responding to the pressure of the investments industry. So certainly that gave me a lot of optimism.
Excellent, thank you, Steph. I like the idea of that washing machine. You'll have to tell us more about that sometime. Joanna?
It's in the energy and efficiency guidelines that Mark mentioned.
Okay, cool.
So it's difficult for me to think of a chemical engineering process, but there's definitely a process in mind that has inspired me, I suppose, and that has all come about from the COVID pandemic. So I guess before the pandemic, something that, or at least when the pandemic was kind of starting to be a thing, or people were starting to discuss it, people said that everybody working from home was impossible because there's not enough like network capacity to enable that. And then the pandemic happened, and we couldn't just stop work. Something had to be done, and because it had to be done, there was a way where everybody could work from home. And now that has shown that this new way of working can still work, and has enabled people to connect from lots of different countries and work together from all over the world. And I think it just shows that if something needs to be done, it can be done, it will be done. We just need to know that it needs to be done. It's easy to think, you know, that's impossible, we don't have the resources to do that, I don't know how we're going to do that, but it's all about what we prioritize in society, in our lives, in business, and yeah, this is a priority, sustainability is a priority, and I think nothing's out of question. So that's the inspiring process for me.
Excellent. Well, thank you for that. And yeah, certainly, it is extraordinary what can be accomplished when people, you know, backs against the wall, and it has to happen. Yeah. Mark, your favourite example? And
yeah, I'm going to pick an example from energy, as you might expect. But I mean, 15 or so years ago, there was very little offshore wind in the UK, as an example, and I was involved with one of the early offshore wind farms and developing offshore transformer stations. And fascinating there to see the engineering expertise coming out of oil and gas in terms of understanding how to design topside facilities and applying them to a very new industry at the time, to put transformer stations offshore to tie back all the wind turbines and bring them to shore. And now, I mean, if you look at the UK, I mean, wind generation, offshore wind generation is a huge part of our energy mix from an electricity point of view, and there's much more being rolled out. So I mean, I think that's an example of something in the last 15 years which has really taken off for me, and has been an example of us translating skills from an oil and gas industry into a renewable industry, because that expertise was there to allow it to happen, and now we're seeing it taking off. And I think, you know, for me, from an optimistic point of view, we therefore, it shows we've definitely got the skills and expertise to just transform the whole world, which is what we need to do, by the way, pretty quickly. And we've got history, right? We did. If you look back over the last 100 years, we've been involved with changing the entire face of the planet in terms of industrialization and production and so on. And so we can do it again. And I think that's what the world is increasingly asking for, with a louder voice for us to do. So I am optimistic. I think we've got the skills. I think just last point really is, in terms of over the last few years, volunteering for IChemE and seeing the motivation and the engagement from all of the members is really, really exciting. And if we all do more of that and get together and use our brains collectively, we've got a really, really good chance of nailing this.
Absolutely. Yeah, thank you, Mark. So last but by no means least, Mary.
I'm going to say a school of thought as my non-linear, or what changed the linear process. I'm going to say servicizing. I hate the term. I love the philosophy. And that is where companies sell the service and they don't sell the product. So Orica sells broken rock. It doesn't sell dynamite. They make sure that dynamite is used as well as possible. They invented throw blasting as a result. Dulux, working in concert with Ford to sell painted doors. They reduced the mass of paint on the doors by almost 50%. Companies selling weed-free fields and not selling pesticides and herbicides. So the focus on the service and not the product, and because that absolutely enhances the partnerships and people working together in supply chain, and it ensures that there's less wastage. And it's not a product. We don't buy stuff because we want to own the stuff. We buy stuff because we want what it presents to us. We don't want a washing machine, we want clean clothes. What inspires me, I think it's been an undercurrent to what everyone's been saying, is human imagination. It's the only thing that is going to rescue us. It's the power of human thought that keeps airplanes in the sky. Well, a little bit of transport phenomena thrown in there, but the human imagination is what's going to get us out the other side of this, and that's what gives me hope going forward.
Excellent. Well, thank you, Mary. I like the power of human thought that keeps planes in the sky. That's another takeaway for me. Awesome. What a wonderful conversation. I hope it's been inspiring. I must thank you for everybody's indulgence, the panelists for being on the call for longer than we asked you to be here, and also for the audience that are still, in vast majority, still online as well. I hope this has been an insightful and thought-provoking and stimulating discussion. It's been the first of what will be monthly discussions on specific topics around chemical engineering, almost all of which are going to reflect back on sustainability in one form or another. So, similar events are going to be held throughout the year as part of the centenary celebrations. So thank you to the panelists. Thank you to Malcolm for his introduction, and actually one huge shout out to the IChemE staff who sit behind the scenes on all of these things. Make it all happen smoothly, and are the unsung heroes of all of this. So huge shout out to the IChemE staff as well. With that, I'm going to close the discussion. Thank everybody for their participation, and look forward to engaging again sometime in the future. Thank you, everybody.
Thank you.
Thanks so much, everyone.
Thanks, Chris. Bye, everyone.
Bye.